So today I'm going to be talking about transcription and translation in prokaryotes and eukaryotes. So I have two little drawings here. First, I have a prokaryote on the left and a eukaryote on the right. So here you can see our circular DNA that is being unwinded for transcription. Here in green we have our mRNA being created. And then here we have our ribosomes in orange that are synthesizing polypeptide chains. Over here we have our DNA, but it's not circular like in the prokaryote. And transcription is occurring here. We're creating our mRNA. mRNA becomes mature, so there are certain steps to that you should probably review if that is necessary for your course. And then this mature mRNA leaves the cell, or not the cell, it leaves the nucleus. That's an important distinction. The purple here is the nucleus, the pink is the cell in total. So the mRNA, it leaves the nucleus and it goes into the cytoplasm, where the ribosomes will then translate the mRNA into those polypeptide chains. So I'm here to talk about the differences here between transcription and translation and just the process as a whole, an overview type of perspective. And something I'd like to bring your attention to for the prokaryote is just, are these things happening at the same time? Is this transcription that's happening here also happening at the same time as the translation creating these polypeptide chains? Well, the answer from this image is yes. Yes, they are. You can see that very clearly the transcription is still occurring here while that same piece of mRNA is already being translated by the ribosomes. In the eukaryote, however, that's definitely not the case. We can see it's being transcribed in this step all the way up here. This is a separate mRNA maturation step to go from pre-mRNA that's just starting to be created here via transcription to the mature mRNA, and then finally it leaves, and that piece of mRNA is becoming translated into those polypeptide chains. So we can see here that this piece of mRNA that's just being transcribed is definitely not also being translated, because that occurs several steps afterwards, denoted by these white arrows. Whereas here there's none of these white arrows. This is all happening simultaneously, and that's a really important distinction to make. In a prokaryote, transcription and translation can happen simultaneously. Let's hope I spelled that right. And then non-simultaneously. So here we have our important distinction. Another thing I wanted to mention is to take note of the prime ends. So when something is transcribed, when the mRNA is transcribed, it always leaves with the 5' end. So you can often see just mRNA hanging off the side once it's being transcribed. So say this is our DNA, and in green we have our mRNA. And so this end here, the end that is sort of falling off, that's already been transcribed while this part is still being transcribed, that's always going to be the 5' end. That's just an easy way you can tell. It leaves first. So that's the same in a eukaryotic cell as well. There's no difference here. You can see that this part of the mRNA, it's already been transcribed. It's hanging off basically. Well, here you can see it's still being transcribed using the DNA. So this is the 5' end. Once it matures, it's still going to be in that same conformation, just for our little diagram's sake. So we have our 5' end still there, which means that our other side must be the 3' end. And then it enters translation with the 5' end. You can see that here. it enters translation with the 5' end, and that's the same here. So you can see it started where it came in at this end, and you can see that this ribosome came first, and the way you can tell that is the length of the polypeptide chain. If it has more over here, more polypeptide chain, that means that it was attached first to the mRNA. Whereas if you compare here, the ribosome has less of a polypeptide chain, which means it was added later. So if you can imagine this mRNA just snaking through here and starting with the 5' end and moving its way through and having these ribosomes attach onto it and then creating these chains of a length that is pretty similar to when they were attached. You can see that again in the prokaryote. The longer polypeptide chain attached itself first, and you can see that makes sense because the 5' end is coming off. You can sort of imagine that attaching first, and then the polypeptide chains get smaller. It denotes that they came in later. So if your teacher asks you, what is the 5' end, what is the 3' end, this is a pretty good hint. So it's important to look at that, and also potentially a question, which ribosome attached first, or which ribosome do you expect to have the longest polypeptide chain, etc., etc. These are all questions that can be kind of answered with this concept. So that's a very basic overview of the differences in transcription and translation in prokaryotes and eukaryotes. It gets a lot more complicated after this, but it's okay. If you take it one step at a time, it will all make sense. Alright, so thanks for watching, and I'll see you next time.